Welcome to Shirtless Talker Chem 101. Today I'm going to teach you the basics of chemistry. And we first need to start off with atoms. You can't have chemistry if you don't first talk about atoms. Now there are protons, neutrons, and electrons. The protons and the neutrons form the nucleus in the middle. The electrons are on the outside, and they are negatively charged. Neutrons, neutral. Very easy to remember. Protons is positive. You can remember that because it starts with a P, or because it has pro in the name. Pro, up, positive. Now, the atoms are the building blocks for elements. You can think of them a bit like real building blocks when you put them together, and it can make other stuff. For example, hydrogen is a type of atom. Oxygen is also another type of atom. You will commonly see numbers above their head. For example, 1 with hydrogen or 8 with oxygen. That is the number of protons. The number of protons in the atom. In a hydrogen atom, it has 1 proton. Oxygen has 8. You ever see the periodic table? The periodic table will have them ordered. A lot of them by groups. If you can imagine the long thing that is drawn out, that is a type of group. Hydrogen is on the left side because it's in a type of group, but is also done by numbers in the rows. Moving on to compounds. H2O is a type of compound because when you take a hydrogen plus a hydrogen and an oxygen, you get H2O. In other words, water. If you did not know that, it's okay. That's why this is Chem 101. Now let's move on to the compounds. For example, another one is NaCl. Do you know what NaCl is? Of course you do. It's table salt. But you can also do it by sodium chloride, NaCl. And what makes up a compound? It's 2 or more different elements. Moving on to the states of matter. We have 3 states of matter here: solid, liquids, and gas. With solid, you can think of it as really clumped up, like ice. There's not much movement in there. It's extremely close together, and they're vibrating, but they vibrate very slowly. And as you can see, there's an ambulance going on outside because they love to learn about Chem 101. They're so excited. The ambulance is so excited that it thought it would toot its horn for Chem 101. Moving back to the states of matter, though, liquid. Your liquids. Take non-frozen water, for example, or any drink that you like. These are a liquid. They're more spaced out, they're less clumped together. And finally, a gas. When you cook and you see the steam coming up, this is a gas. Also when you fart. Number 6, chemical versus physical changes. I have a question to ask you. What is the difference between chemical and physical changes? Now, I have zero idea what you said, but the answer is that physical doesn't actually change the properties of it, versus chemicals does. So I'm going to ask you another question here. Melt ice, burn wood. Burning wood or melting ice. Which one is a chemical change? And which one is a physical change? Well, the answer, of course, melting ice, remember, that's when these really tight molecules start to become spaced out. Extremely tight molecules. Versus burning wood. That is a chemical change because there is some chemical change going on. Very simple stuff. Another example of a physical change would just be cutting paper. That's obviously very different than burning wood. An example of another chemical change would be rust or baking bread. And finally, let's move on to one of the rules of chemistry, conservation of mass. Mass can never be created nor destroyed. It really makes you think about why is everything anything at all? Not to change this into a philosophy lecture, but all of these rules exist. Why do they exist? How did they come about? Those are questions for another time. Thank you for joining me on Chemistry 101, and I hope you have an amazing rest of your day.